Yes, students, now we are going to see sixth problem in exercise 6.2 in our series. So what is given? In the given figure, PQ and RS are two mirrors. Two mirrors. So if we are given the lines like this means this is the opaque face and this is the reflecting surface. So the plain line, the inwardly seeing surface is a reflecting surface. Likewise in RS, that is a reflecting surface. So they are kept parallel to each other. An incident ray AB strikes the mirror PQ at B, and after incidence it is getting reflected. The reflected ray moves along the path BC and again it strikes this mirror RS at C, and again it reflects back along CD. What we need to prove is, we need to prove AB is parallel to C. This is what the problem. What we are going to do with that is, the clue given is these two are the mirrors. And moreover, they said this is an incident ray and this is a reflected ray. So as per the law of reflection, we know angle of incidence will be the angle between the incident ray and the normal drawn to the surface of reflecting surface. Angle of incidence is the angle between the incident ray and the normal, that is the normal, the perpendicular line drawn to the reflecting surface. Likewise, angle between the reflected ray and the normal is the angle of reflection. So this is angle of incidence and this is angle of reflection. As per the law of reflection, we know angle of incidence is equal to angle of reflection. In the same way, when we draw a normal to this line, that is the reflecting surface, this is perpendicular to the reflecting surface. Okay, let's say this is X and this is Y. Okay, this is a normal drawn to this reflecting surface. So for this surface, this is the incident ray and this is the reflected ray. So angle of incidence is this angle of incidence and this is angle of reflection. Angle of reflection, and now we know angle of incidence here also equal to angle of reflection according to our law of reflection. So what happens now, angle ABX is equal to angle XBC for this case. As such, for here angle of BCY is equal to angle YCD as per our law of reflection. Okay, now because these two are the perpendicular lines drawn to these two parallel lines, they themselves are parallel to each other, because this is a perpendicular line drawn to this, the normal, and this is another perpendicular line drawn to this parallel line which is parallel to it. So because these two are parallel and the perpendicular lines also will be parallel. Okay, for these two parallel lines, this will be as a transversal. BC will be the transversal. If we take these two are parallel to each other, that is BX as BX parallel to CY, angle XBC will be equal to angle BCY. DC is transversal. BC is transversal. Okay, now Because XBC is equal to BCY, we can also say all these angles are equal because these two are equal now we stated. So altogether all are equal. Okay. So we can now say angle ABX equal to this, and we can equate this also because these two are equal. We proved that these two are equal. So now all these angles become equal to each other. So that we can state ABX plus XBC will also be equal to angle BCY plus angle YCD because all are equal. Okay, this angle ABX plus XBC, ABX plus XBC is nothing but our angle ABC. So here I can replace my angle ABC. Then again angle BCY plus angle YCD is nothing but my angle BCD. Angle BCD. So if angle BCD, ABC is equal to angle BCD, AB will surely be equal to CD. AB is parallel to CD because for AB parallel to CD line, if these two are parallel lines, this angle and this angle are the alternate interior angles. So AB is parallel to CD now, because of which these two angles are equal. They are alternate interior angles. ABC equal to BCD, alternate interior angles. Alternate interior angles. So AB is proved to be parallel to CD. Hence proved. I hope you understand, children.